Students. So in the last class, in the last chapter, we have read that how a motion is happening, what is motion, what is rest, and we have actually read the three equations of motion. Okay, so these three equations are actually based on the prediction. That means with the help of these three equations, you can predict a motion. So if you know what is the rate of change of displacement with respect to time, and if you know what is the rate of change of velocity, okay, then you can obviously you can predict the motion. That means how much the particle is traveling, in what time it is traveling. And we have analyzed the motion in one dimension as well as in two dimension. In case of two dimension, that is the motion in a plane, we have segregated the motions into two parts. That means into two one dimensional problems, and then we have solved it. Example, projectile motion. Now that means in the last chapter we have read only about the properties of motion. That means if the motion is happening, then how it will behave. But in the new chapter, we are going to learn what causes motion, what influences motion, and how to change motion. So basically, these all things are kept inside this three words, that is laws of motion. So if we study the laws of motion, eventually we will get to know about the causes of motion and what influences it. Okay, so basically when we are studying laws of motion, the first name that will come, that is Newton. In the early era, Aristotle told that any object stops after rolling a while due to its lethargy. That means the object become tired, and because of fatigue it stops. But as our society and our intelligence reshaped, and Newton find out three laws of motion. So before we go into the laws of motion, we first try to understand what is a state of object. So state of object, any objects. Okay, so the state of objects are actually based on two categories. One is your motion, that means the object can be in motion, and the object can be in rest. Now these two things, motion and rest, these states are actually apparent, or you can say subjective. Something may be beautiful to you, but that thing can be ugly to others. So that means in the same way, motion and rest is subjective. Now why this is subjective? Let us say that you are going in a train, that is train A, and through your window you are looking at another train which is going in the same direction, that is train B. The velocity of the two trains are same. Okay, so when the velocities of two trains are same, so when you are looking at another person that is in B train, you might see that the person is as motion, is in rest with respect to you, because you are saying he is not moving and he is going with you. So that means a person who is standing at the station, he will see that both of you are actually moving, but you are seeing that the person at B train is at rest, and the person who is standing in the station is going in the backward direction. So this motion is basically apparent. Now one more thing is that one more example you can take as the rotation of Earth. Now we all know that the Earth rotates around its axis. So that means you are also moving, I am also moving. But when we sit in a chair, like you are also sitting, I am also sitting. So for you, I am at rest, and for me, you are at rest. But if somebody is seeing from outside, let's say in any like spacecraft, somebody is looking at us, so he will see that both of us is moving actually. So that means the motion is always subjective. Then the question is how to define any motion. So to define any kind of motion, the main thing we need is a reference. Now what is a reference? Reference means, let's say there is a tree and you are running. So you are running, okay, and there is a tree. So what I can say that you are in motion with respect to the tree. That means if I stand here with the tree, I will see that you are running. But if I run also with the same speed as much as you, then what will happen? For me, you will be at rest, because you and me both are running together. So in that case, what we have to say, like if something is at motion, so I have to say that you are in motion with respect to the tree. So this is the thing which is called reference. But generally, for our mathematical calculation, what we will do, we will take the frame of reference. That means, let's say this is the axis I have taken, and I have taken the origin, that means the initial point, the starting point over here, okay, and this is my x-axis, this is my y-axis. Now if any object, let's say this object P is moving in this direction, so I must say that the P object is in the motion with respect to the reference frame xy, whose origin is at O. So to define motion, we must give some reference. Okay? Achha. And one more thing which will be helpful in further study, maybe if I am taking a reference coordinate system like xy in this case, and if I don't have any kind of acceleration here, so if my acceleration is 0, this reference frame is called inertial reference frame. Now I will come to this term slowly. So inertial reference frame. Okay. Now let us come to the three laws of motion, as we have little bit known about the nature of motion. The nature is subjective. That means when you are defining any motion, you must give some reference point. Okay. Now coming to the Newton's first law of motion. Now you all, like most of you knows about the three famous laws of motion. So the first laws of motion, Newton has told that if any object is at rest, then it will be at rest forever. Again, like if something is moving with some constant velocity v, then it will be moving with that velocity forever, provided there is no external force. Now slowly if we now you are in the higher studies, so we should not only just utter the sentence, but also realize the fact what is happening. Now every object is having one unique property, and that property is kind of laziness to stay in that state in which the object is at present. Like if something is at rest, so it wants to be at rest forever. And if something is moving with some specific velocity, then it wants to move with that velocity. So it does not want to change its state. So a laziness works in objects which promotes the object to be in its state of motion. So every object is having this kind of property, and this property or one kind of laziness is called inertia. So inertia is a kind of property with what every object wants to be in its own state. Now, if you talk about this inertia, so we might say that like how it depends on the object. Like if I have earth, if I talk about earth, and if I talk about a small marble, is there the same inertia? So let us talk about a very fat person. He is really fat, okay, very big, and there is a very tiny person. Now obviously if the fat people is sleeping, like to wake him up and to make him get out of the bed, it is a really hard job, and it is a hard job for him also. I'm not underestimating them, like I'm just talking about a fact, okay, so take it as a fact only. And if I talk about a tiny people, so you can see that easily he can get up, okay, little bit of laziness is there, but he can get up, means like so in the same scenario happens in kind of inertia and on objects. So if we talk about two objects, let's say one object is having m1 mass and one object is having m2 mass, then this inertia is linked with, let's say because it is the laziness, so it is always linked with the change of state, because you can see that whose laziness is higher, to change his state we have to do more effort, right? But whose inertia is lower or the laziness is lower, we have to do less effort. Now you can see one thing, that if you just give a small small hit in the ground, that means you are actually hitting the earth, right? So when you hit the earth does not move. But when you hit any small objects, okay, like a marble or a ball, you see that the object moves immediately. But you are giving the same effort in the both cases. Now the question is that if you are trying to change their state, why the earth is not moving noticeably in a noticeable amount, and why the ball is moving in a noticeable amount, like you can see how the ball is moving. But if I jump even, the earth does not move. So what is the thing? That means there is some property which depends on the mass of that object. So that means in this case mass is playing a vital role to create the laziness of any object so that it can stay in its own state. So we can say one thing, that this inertia is also that thing which is the laziness. So inertia is directly linked with the mass. So in the simple word, we can say that the mass is a direct representative of this inertia, which is the nothing but the laziness with what the object wants to stay in its own state. Now if we come into the Newton's first law, which was told that any object wants to be in its state, any object wants to be in its present state. So that means if some like whatever is the final initial velocity, that will be the final velocity forever, provided if no external forces. Now I'm not using the term force because I will come to that, so I'm writing influences. So if no external influences is there, is acted on, you can say like this, is acted on. So this is the basically first law of Newton, right? Okay, now coming to the second law. Now the question is coming that okay, fine, now I know what is inertia and like how the state of any object like behave, okay, like how any object behaves for its state. So now the question is then how to influence and change the state. So one thing we can see here, that if we have, so when we have two objects, let's say one is having mass m1, one is having mass m2. Let's say we are talking about again earth and any small ball. Okay, so we know that m1 is much greater than m2. That is the then also the inertia of earth is much greater than the inertia of the ball. Okay, so this is our earth and this is our ball. And also the like that means the earth will give you more hindrance when you are trying to change its state rather than the ball, okay, which will give you less hindrance when you are going to change its state. So that means here in case of earth you have to give more effort. Now if one more thing is there, how we change a state. So that means if something is at rest and you want to make it in motion with some specific velocity v, that means you have to give it the motion. That means you have to transport something to it, right? Because it was at rest, so it was not having any kind of energy right that time. So that means you have to give something, you have to transfer something so that the state can change, right? So like if you remember about carom board, okay, so if we talk about a carom board, so one thing we can see here, when we have a carom board like this and you have a small striker, okay, you have a striker like this, change the color, okay, you have a striker like this and you have a small coin even. So sometime it happens that if you strike this, okay, if you strike the coin, strike the striker to the coin, what happens? Suddenly it happens sometime that the striker stops there and the coin start moving, right? That means the striker was initially having some velocity and now it has transferred this to the coin so that the coin can move and the velocity of the striker become either zero or it become lesser than the before. So that means something is being transferred from this striker to the coin. So what is that thing which is transferred? One thing we can see noticeably, that is the velocity which is transferred. So velocity, one portion of the velocity is transferred from the striker to the coin. Now the question, if only velocity matters when you are trying to change the state, then if I strike a small ball to the earth and if I strike that ball with another ball, so they should have the same velocity which the ball has transferred. That means if the ball was coming with v velocity and the ball has transferred to the earth the same amount of velocity, that is v. So and in the next case, this ball again it was coming with velocity b, and now it has transferred the full velocity v to another ball. We can see that this ball will have some influences from this ball and it will move. But in case of earth, if the same thing is happening, do you think the earth will also move with that v velocity? No, it does not move. Whereas this ball can move with that velocity which this ball has transferred. So why? That means to change the state, only transferring velocity does not matter. With that, something also matter, which is nothing but inertia. That is the laziness. So which will have more inertia? If you transfer velocity to it, obviously it will show you less interaction. That means it will have less influence. So that means to change the state of any matter, so I am writing this clearly, that to change the state of matter, the state of object, not only velocity transferred matters, but also the inertia plays a vital role. Inertia, which is nothing but your mass, plays a vital role. So this is a very important conclusion here. So ultimately we can see that some quantity which is combination of your inertia and your velocity actually needed so that we can change the state of the matter. And here something comes which is called momentum. So this term is nothing but the combination of your inertia and your velocity. So we can say this is nothing but m and v, and it is denoted with p generally. So we have a term which is called momentum and which is responsible to change state of matter or state of motion. So momentum is the thing that plays the vital role. Now, how the momentum changed the state? Let us talk about that simple experiment that or the simple realization that I was talking about. Let's say this is a ball and this is another ball here. So you can see that let's say this is ball A and this is ball B. So ball A transferred some amount of velocity to ball B, so that the ball B is now having a velocity, let's say v2. So initially ball B was also moving and ball A was also moving, but ball A has transferred some velocity, extra velocity to ball B, so that its velocity has increased. So initially ball B was having velocity v1 and this is finally it was having velocity v2. So that means something has been transferred to it so that it has changed the state, because it was moving with velocity v1 and now it is moving with velocity v2. Now the question is that this ball BA, this A ball has transferred some velocity to ball B, but whose inertia is working here for the changing of state? Obviously it's B's inertia, right? Why? Because see, whose state is changing? B ball's state is changing. So that means B ball will show its laziness to not to change its state. So ultimately what we can write, that the influence given which has changed the state of that ball is nothing but the initial momentum, or we can say the final momentum, minus initial momentum, and that will show how much the state is changed. So we can say that if the mass of this ball is m, so this is m v2 minus m v1. So that means it is nothing but p2 minus p1, that is the change in momentum. So this is the influence that I am giving. Now the question is that in how fast the state is changing. So I must know, I know that the state is changing here, right? But how fast the change is happening? So for that I have to consider a parameter time. That means I have to see what is the rate of change of that, what is the rate of transfer of this momentum which A is transferring to B. So obviously A ball is transferring the momentum to B. That means how fast it is happening. So how fast it is transferring. So to know that the rate of influence given by ball A is your P2 minus P1 by time. That means the how much faster it is happening. And this thing, the rate of influence, is nothing but the term that is with that you are much familiar, that is your force. So this is P1 minus P2 by T, which I can write as mv2 minus mv1 by T. Further I can write m v2 minus v1 by T, and this is nothing but your acceleration. So this is m into A. So the famous equation that we are getting right now, F equal to m into A, comes like this. And this is the second law of motion given by Newton. That is, the force is equal to mass into acceleration. So actually what is the force? Force is nothing but the influence, the rate of influence given by some objects to another object. So we can say that the force is basically the rate of change of its like that object's momentum, you can say like that. One more thing is that we have seen that F equal to P2 minus P1 by T. So from here we can get that P2 minus P1 is equal to F into T. Now this term is called impulse of force. What is the impulse of force? Basically, impulse of force is nothing but the total influences given by this, in this case, given by the ball A. That means how much total transfer of momentum has happened. So that is given by this P2 minus P1, that is the change in momentum, that is equal to nothing but your force into time. Now but because Newton has done this wonderful job, so that's why the unit, the SI unit of force is Newton. Okay, fine. So today, one more thing is there. There is another thing called impulsive force. So there is a huge difference between these two. impulsive force and impulse of force are not same. Impulsive force means what? When you hit harder with very less time interval, like when you strike the ball with a bat. So when you strike the ball with a bat, in that case the contact point, or the the transfer of the momentum by the bat to the ball is very very instantaneous. That means it happens quickly with very less amount of time, and it is a huge amount of force. So when it happens, then it is called impulsive force. But impulse of a force and impulsive force are not the same thing. Okay, so these two things are really important here. The one thing I have missed actually, that is dimension. So after like these three laws of motion, we will talk about dimension a little bit, which is easy only. Okay, so today 1 and 2, these two things we have done. So the third thing is left, and that is the reaction. Why I am leaving that? Because with reaction, that is the third law, every action has opposite and equal reaction. This third law will give us a lot of conclusions. Okay, so that will take another class. So for now, today what we have learned what is inertia. Inertia depends on the mass. In the we have talked about reference frame. We have also learned about this, how the state can change, how we transferred momentum, and how how the object gives some hindrance to our influences. So basically this is it. So we have to realize, okay, this is not merely just two laws, but this is one kind of realization ki how our world works. So for now, this much is today, and we will meet in our next class. Till then, stay tuned. Just for say.